Development of NGAD's advanced AI systems by 2024, 5 critical phases and $1.2 billion investment allocation. Overview. The Next Generation Air Dominance NGAD initiative represents a transformative leap in military aviation technology, specifically through the integration of advanced artificial intelligence AI systems. With an investment allocation of $1.2 billion for the year 2020, the U.S. military aims to enhance its aerial combat capabilities through a structured development process organized into 5 critical phases. Key phases of development. The development of NGAD AI systems is divided into 5 distinct phases, each designed to systematically build on the previous stage, ensuring thorough research, testing, and integration into operational frameworks. 1. Phase 1, Research and Development. The journey begins with in-depth research and development. This phase is aimed at exploring various AI algorithms and machine learning techniques that can be applied to aerial combat scenarios. Collaborations with academic institutions and tech firms are crucial, as they provide innovative approaches and cutting-edge technologies. The focus here is on foundational studies that establish the groundwork for more advanced applications in later phases. 2. Phase 2, Prototype Development. Once the foundational research has yielded promising results, the next phase is the creation of prototypes. This stage is vital for bringing theoretical concepts into practical applications. The prototypes will be rigorously tested in simulated environments to assess their potential effectiveness and identify necessary adjustments. This iterative process ensures that any bugs or deficiencies can be addressed before moving forward. 3. Phase 3, Testing and Validation. In this phase, prototypes undergo extensive testing to validate their performance in conditions that mimic real-world scenarios. The complexity of aerial combat necessitates that these systems can operate reliably and effectively under various circumstances. Testing will include simulations of enemy engagements, environmental challenges, and other stress tests to confirm that the AI systems can function as intended in dynamic operational theaters. 4. Phase 4, Integration and Training. Following successful validation, the AI systems will be integrated into existing military platforms. This phase is not just about technology, it also encompasses the training of personnel who will work with these advanced systems. Ensuring that aircrew and ground support staff are familiar with the new technologies is crucial for operational readiness. Training programs will focus on how to interact with, manage, and troubleshoot the AI systems in combat scenarios. 5. Phase 5, Deployment and Feedback Loop. The final phase involves the deployment of these advanced AI systems into active service. However, the process doesn't end there. A robust feedback mechanism will be established to monitor performance in real time, enabling ongoing improvements and refinements. This adaptive approach is essential for maintaining the effectiveness of the systems as combat environments evolve. Investment allocation. The $1.2 billion investment for 2024 will be strategically allocated across the 5 phases of development. A significant portion is dedicated to advanced research and prototype testing, which are critical to the success of the overall initiative. This financial commitment underscores the U.S. military's recognition of the importance of AI in future warfare and its determination to lead in this domain. Common key points across sources. Several key themes emerge from various discussions surrounding the NGAD initiative. AI as a force multiplier. There is unanimous agreement that AI technologies will serve as force multipliers in aerial warfare, enhancing decision-making, situational awareness, and operational effectiveness. Collaboration is key. The emphasis on partnerships with technology firms and academic institutions highlights the necessity of a broad-based approach to innovation. Rigorous testing and validation. Ensuring reliability through comprehensive testing is a common priority among stakeholders given the high stakes of aerial combat. Learning and adaptation. The goal is to develop systems capable of learning and adapting over time, which is essential in the fast-paced and ever-changing landscape of military operations. Differences between sources. While many sources align on the general structure and investment of the NGAD initiative, some differences arise in the emphasis placed on certain aspects. Ethical considerations. Some reports delve into the ethical implications of AI in warfare, particularly regarding autonomous decision-making in combat, raising questions about accountability and the potential for unintended consequences. Strategic importance. Other sources highlight the strategic necessity of maintaining air superiority and frame the NGAD project as critical for national security, emphasizing its role in deterring adversaries. Timeline of events. The projected timeline for the NGAD initiative outlines a clear path forward. 2022 to 2023, initial research and development phases began focusing on exploring various AI technologies and establishing foundational frameworks. 2024, prototype development and initial testing are set to commence, aiming for operational readiness within the following years. 2025 to 2026, continued testing and validation efforts will lead to early integration of the systems into Air Force operations. 2027 and beyond, full-scale deployment of the AI systems is anticipated, accompanied by ongoing improvements driven by operational feedback. Conclusion. The development of NGAD advanced AI systems signifies a major investment in the future capabilities of the U.S. military. Through a methodical approach encompassing research, testing, integration and deployment, the initiative aims to position the Air Force at the forefront of aerial combat technology. The emphasis on AI not only reflects the changing nature of warfare but also highlights the importance of strategic planning and ensuring air dominance in future conflicts. The NGAD initiative stands as a testament to the U.S. military's commitment to embracing innovation and maintaining its competitive edge in global defense. 1. Counterintuitive focus on collaboration. It may seem logical for the military to rely solely on internal resources for the development of AI systems, considering national security concerns. However, the emphasis on collaboration with academic institutions and private tech firms indicates a recognition that innovation often arises from diverse perspectives and expertise outside of traditional military environments. This approach could lead to breakthroughs that might not be achievable through insular development processes. 2. Investment distribution. While the total investment of $1.2 billion seems substantial, the distribution across 5 phases suggests a more cautious and iterative approach rather than a rapid rollout of technology. This could be counterintuitive in a field where speed is often equated with superiority, as it indicates a preference for thorough testing and validation over hastily deploying potentially unproven systems. 3. Ethical implications. Although the focus is primarily on enhancing combat capabilities, the ethical discussions surrounding AI in warfare are gaining traction. This duality, advancing technology while grappling with moral implications, could seem contradictory. The military's acknowledgement of these concerns highlights a nuanced understanding that technology's benefits must be weighed against potential misuse or unintended consequences. For feedback loop importance, the inclusion of a feedback mechanism in the final phase of deployment is notable. Typically, one might assume that once systems are deployed, the focus would shift entirely to operational effectiveness. However, the recognition that ongoing improvements based on real-world performance data are essential indicates a commitment to adaptability in a rapidly changing combat landscape, which may not align with traditional military practices of static operational protocols. 5. Long-term timeline. The projected timeline extending to 2027 and beyond may appear counterintuitive given the urgency often associated with military innovations. The extended development and integration phases suggest a strategic mindset, prioritizing reliability and effectiveness over immediate dominance. This could reflect an understanding that advanced technology, particularly AI, requires time to mature and integrate successfully into complex military operations. 6. AI as a force multiplier. The assertion that AI will act as a force multiplier might seem self-evident, but it challenges the traditional view of air superiority, which has historically relied on sheer numbers and advanced hardware. By framing AI as an enabler that enhances the capabilities of existing platforms rather than simply replacing them, the initiative suggests a paradigm shift in how air dominance is conceptualized and achieved. 7. Integration over replacement. The focus on integrating AI systems into existing platforms rather than replacing them with entirely new systems might seem counterintuitive in a field that often prizes cutting-edge technology. This approach indicates a strategic choice to maximize current assets and enhance their capabilities, rather than incurring the costs and risks associated with developing entirely new systems from scratch. 8. Operational readiness through training. The emphasis on training personnel to work with advanced AI systems highlights a counterintuitive realization: technology alone cannot ensure success in combat. The understanding that human operators must be effectively trained to leverage AI capabilities challenges the notion that advanced systems can autonomously perform without skilled oversight. 9. Complex aerial combat scenarios. The rigorous testing of prototypes in complex aerial combat scenarios may appear to contradict the notion of AI's superiority in decision-making. The military's insistence on validating AI performance in challenging environments underscores the reality that while AI can enhance decision-making, it is not infallible and must be tested against the unpredictable nature of warfare. 10. Strategic national security perspective. While the NGAD initiative is rooted in technological advancement, its framing as essential for national security reflects a counterintuitive acknowledgement that technological superiority alone does not guarantee safety. The strategic focus on maintaining air superiority suggests a broader understanding of warfare that encompasses geopolitical dynamics and the importance of readiness in the face of evolving threats. These counterintuitive insights reveal the complexities and strategic considerations involved in the development of advanced AI systems for military applications, highlighting a multifaceted approach that balances innovation ethics and operational realities. In the report regarding the development of next-generation air dominance NGAD advanced AI systems, several important aspects may be overlooked by the general audience, even though they hold significant implications for the future of military aviation and national security. 1. The role of AI as a force multiplier. One of the critical points often underestimated is the concept of AI as a force multiplier. This term refers to technology that enhances the effectiveness of existing military capabilities. The integration of AI in aerial combat is not just about automation but also about augmenting human decision-making processes. The ability of AI systems to analyze vast amounts of data in real time and offer strategic suggestions can significantly enhance the situational awareness of pilots and commanders. This improvement in decision-making speed and accuracy can drastically alter the outcomes of aerial engagements, making it essential for maintaining air superiority. Significance. Understanding AI as a force multiplier illustrates the transformative potential of these technologies in warfare. It's not merely about replacing human roles but enhancing them, allowing military personnel to focus on higher-level strategic decisions while AI handles data analysis and operational tasks. This shift could redefine the dynamics of air combat with implications for tactics training and resource allocation. 2. Collaboration with tech firms and academic institutions. The report highlights collaboration with private tech firms and academic institutions, yet the depth of this collaboration's significance is often overlooked. Partnering with these entities not only brings fresh ideas and innovations but also ensures that the military remains at the forefront of technological advancements. This engagement allows the military to leverage civilian advancements in AI and machine learning, which can accelerate the development of effective systems. Significance. Such collaborations can lead to the rapid prototyping of technologies that may not have been developed in a traditional military context. The cross-pollination of ideas between military and civilian sectors can foster innovative solutions to complex problems. Moreover, This approach mitigates risks associated with insular development practices, ensuring that military applications are grounded in the latest technological breakthroughs. 3. Ethical implications of AI in warfare. While some sources touch upon the ethical implications of AI in warfare, this discussion is often superficial. The potential for autonomous decision-making raises profound ethical questions about accountability in combat scenarios. If AI systems are responsible for making life-and-death decisions without direct human oversight, who is held accountable for mistakes or unintended consequences? This issue is particularly pressing given the increasing complexity and unpredictability of modern combat environments. Significance. Neglecting the ethical dimensions of AI in military applications could lead to severe consequences, including public backlash, international condemnation, or even violations of international law. Addressing these concerns proactively is crucial for maintaining public trust and ensuring that technological advancements align with moral and ethical standards in warfare. This discourse must include developing guidelines and frameworks for responsible AI use, particularly in high-stakes environments like military operations. 4. The feedback loop for continuous improvement. Another often overlooked aspect is the establishment of a feedback mechanism post-deployment. The report indicates that there will be a focus on gathering performance data to inform ongoing improvements. This iterative process is vital for refining AI systems and ensuring they adapt to new challenges and threats effectively. Significance. The significance of a feedback loop lies in its ability to create a learning system that evolves over time. This is particularly relevant in the context of warfare, where adversaries are continually developing new tactics and technologies. An AI system that learns and adapts based on operational feedback can provide a significant advantage, allowing for quicker adjustments to strategies and tactics. This adaptability can be crucial in ensuring sustained air dominance in the face of evolving threats. 5. Long-term strategic importance. Finally, while the report outlines immediate phases and allocations for the NGAD initiative, the long-term strategic implications of this investment are often understated. The commitment to advanced AI systems is not just about enhancing current capabilities but also about positioning the U.S. military to face future challenges in an increasingly complex global security environment. Significance. The long-term strategic importance of developing NGAD systems reflects a broader recognition of the changing nature of warfare, where technological superiority will play a decisive role in future conflicts. By investing in AI technologies now, the U.S. military aims to maintain a competitive edge not only against peer adversaries but also in countering asymmetric threats. This foresight is critical for ensuring national security and preparing for unforeseen challenges in the coming decades. Conclusion. In summary, while the report on the NGAD initiative outlines clear phases and investment strategies, several critical components warrant deeper consideration. The role of AI as a force multiplier, the significance of collaborations with tech firms, the ethical implications of autonomous warfare, the importance of ongoing feedback for improvements, and the long-term strategic outlook are all crucial elements that could reshape the future of military aviation. Recognizing and addressing these factors will be essential for maximizing the effectiveness of the NGAD initiative and ensuring that the U.S. military remains at the forefront of technological advancements in warfare. 1. Investment in AI as a force multiplier. The emphasis on artificial intelligence as a critical force multiplier in aerial warfare underscores the transformative potential of AI technologies. This point invites an in-depth analysis of how AI can enhance decision-making, improve situational awareness, and automate complex tasks in combat scenarios. The integration of AI systems into military operations could drastically reshape the dynamics of aerial engagements, necessitating a discussion on the implications for strategy, tactics, and overall military effectiveness. 2. Collaboration with tech firms and academic institutions. The NGAD initiative highlights the importance of collaboration with private technology companies and academic institutions. This collaboration is vital for fostering innovation and ensuring that the military leverages cutting-edge research and technological advancements. Analyzing the role of public-private partnerships in defense technology development can provide insights into how the U.S. military is adapting to the rapidly evolving tech landscape as well as the advantages and challenges of such collaborations. 3. Rigorous testing and validation protocols. The emphasis on rigorous testing and validation of AI prototypes is crucial for ensuring reliability and effectiveness in real-world scenarios. This point raises important questions regarding the methodologies used for testing AI systems, the benchmarks for success, and the ethical considerations surrounding their deployment in combat. A deep dive into testing protocols can illuminate how the military plans to mitigate risks associated with AI in high-stakes situations and the potential consequences of failures in these systems. 4. Ethical implications of autonomous decision-making. The discussion surrounding the ethical implications of AI in warfare, particularly concerning autonomous decision-making, is increasingly relevant. As military systems become more autonomous, the potential for AI to make life-and-death decisions raises significant ethical concerns. An in-depth exploration of these ethical issues, including accountability oversight, and the moral implications of AI-driven combat, can contribute to a broader understanding of the societal impacts of military AI technologies and the ongoing debates about their use in modern warfare. 1. The Manhattan Project 1942–1946. The Manhattan Project was a pivotal research and development project during World War II that produced the first nuclear weapons. Initiated in response to fears that Nazi Germany would develop atomic bombs, the project involved collaboration among top scientists, military officials, and government agencies. The program was structured in phases similar to the NGAD initiative, including fundamental research, prototype development, the first atomic bomb, extensive testing, Trinity test, and eventual deployment, Hiroshima and Nagasaki. The project required significant investment and showcased the importance of scientific innovation in warfare. 2. The Apollo Program 1961–1972. The Apollo program was a series of space missions conducted by NASA aimed at landing humans on the Moon and ensuring their safe return to Earth. Initiated by President John F. Kennedy, the program involved multiple phases including research and development of spacecraft, building prototypes, Apollo lunar module, extensive testing, e.g. Apollo 1 tragedy leading to redesigns, training astronauts, and finally the deployment of missions that led to the historic Apollo 11 landing in 1969. The program required significant funding and collaboration with academic institutions and private companies, reflecting the strategic importance of advancing technology. 3. DARPA's Autonomous Systems Program 2000s present. The Defense Advanced Research Projects Agency DARPA has been at the forefront of developing autonomous systems for military applications, especially in aerial and ground vehicles. This program includes phases of research and development focused on advanced AI prototype creation, testing such as the DARPA Grand Challenge for self-driving vehicles, integration with existing military platforms, and ongoing operational feedback. The initiative illustrates the military's commitment to harnessing AI technologies to enhance operational capabilities and maintain strategic advantages in modern warfare. The development of next-generation air dominance NGAD advanced AI systems by 2024 signals a transformative shift in military aviation, emphasizing the integration of artificial intelligence into modern warfare. With a projected investment of $1.2 billion, the initiative is structured into 5 critical phases, each designed to enhance the U.S. Air Force's capabilities and maintain air superiority. Below are predictions regarding the future outlook of this initiative. Predictions for future outlook. 1. Acceleration of AI technology advancements. By 2024, we can expect rapid advancements in AI technologies specifically tailored for military applications. This will likely include improvements in machine learning algorithms, data analytics, and autonomous systems that can process vast amounts of information in real time. The collaboration with tech firms and academic institutions will foster innovation, leading to breakthroughs that enhance decision-making and operational efficiency in aerial combat. 2. Enhanced simulation and training programs. The prototype development phase will lead to the creation of sophisticated simulation environments. These simulations will not only aid in testing AI systems but also revolutionize training programs for personnel. Expect to see immersive training scenarios that incorporate virtual reality (VR) and augmented reality (AR), allowing pilots and operators to engage with AI systems in a controlled yet realistic setting. This hands-on experience will ensure that personnel are well prepared to operate alongside advanced AI technologies. 3. Integration of ethical AI frameworks. As discussions surrounding the ethical implications of AI in warfare gain momentum, the NGAD initiative will likely adopt ethical frameworks for the deployment of AI systems. This will involve establishing guidelines for autonomous decision-making, ensuring that human oversight remains a crucial component in combat scenarios. The military may invest in developing transparent AI systems that can explain their decision-making processes, thereby addressing public and ethical concerns regarding the use of AI in warfare. 4. Real-time data utilization and adaptation. The NGAD systems will be designed to adapt to real-world combat conditions through continuous data collection and analysis. The feedback loop established in the final deployment phase will facilitate ongoing improvements, enabling AI systems to learn from their experiences in the field. This adaptive capability will enhance the effectiveness of air operations, allowing for more dynamic responses to evolving threats and challenges in the operational environment. 5. Shift toward multi-domain warfare. The integration of NGAD AI systems will likely catalyze a broader shift toward multi-domain warfare strategies. As air, land, sea, cyber, and space operations become increasingly interconnected, the ability of NGAD systems to communicate and coordinate with other military assets will be essential. This will result in a more holistic approach to combat, where air dominance is achieved not just through individual systems but as part of a cohesive multi-domain operation strategy. 6. Increased budget allocations and long-term investments. Given the strategic importance of air dominance and the anticipated success of the NGAD initiative, future budgets are likely to see increased allocations for AI research and development beyond the initial $1.2 billion. Congress and defense agencies may recognize the need for sustained investment to keep pace with technological advancements and to ensure that the U.S. maintains its competitive edge in military aviation. 7. Emergence of international collaborations and complications. As the U.S. advances its NGAD initiative, we may witness increased international collaborations in the field of military AI technologies. Allied nations may seek partnerships to develop similar capabilities, potentially leading to joint operations and shared technologies. Conversely, this could also spur an arms race in AI-driven military systems, prompting other countries to expedite their own AI advancements, raising geopolitical tensions. Conclusion. The future of the NGAD Advanced AI Systems Initiative by 2024 is poised to significantly reshape military aviation and the broader landscape of warfare. As the U.S. invests in cutting-edge technologies and navigates the complexities of ethical considerations, training, and operational integration, the outcomes will not only enhance air dominance but also redefine the role of AI in military operations. The emphasis on continuous improvement and adaptation will be crucial as these systems are deployed, ensuring that the U.S. remains a formidable force in an increasingly competitive global environment.